The stream has been created. Let's look at some of the details. The capacity mode is on demand. The data retention period is 1 day. The maximum record size is 1 MB or 1024 kilobytes. And then we have the ARN of this Kinesis data stream. In the bottom, we have producers. There can be three different type of producers. One is Kinesis agent. Then we have AWS SDK. We can use AWS SDK for Java, for Python, etc. We have something called Kinesis Producer Library or KPL. We'll talk about it in the next video. Then we have consumer applications, and consumer applications can be Apache Flink, Glue Streaming, Data Firehose also, or Kinesis Client Library, which can be used to develop consumers using programming languages like Java, Python, etc. We'll not use KCL and Apache Flink in our course. We'll be using Data Firehose and Glue Streaming also. And right now I have not created any producer or any consumer whatsoever. Let's go to the monitoring tab, and here you have multiple different stream metrics. Now, what are the metrics? First is the get records. How many number of records have been retrieved from the stream? There's something called iterator age. We'll talk about iterator. Then the latency. What was the latency to read the records from the stream? The number of record count. This is the count per second. This is the megabytes per second or maybe bytes per second. Similarly, you have incoming data in megabytes, then in count. Then you have put record, which is used to write data to the Kinesis stream. We have put record latency also, which will show you the latency that was incurred while writing records to KDS. The success message, the number of records, latency, etc. So you can get a lot of monitoring metrics here. Then we have configuration. So in the configuration, we have the capacity mode and we have something called warm throughput. We can change the capacity mode. You can click in edit capacity mode. Currently it is on demand. We can change it to provisioned, and we can mention the number of shards. So once you change it, you can set it back to on demand when provisioned are not needed. So you can have a mix and match of capacity mode also. And that would be needed for scenarios like predictable workload throughout the day, but spiky in some time, and you do not know how many records would come. So in that case, you can combine both provisioned and on demand together. So let's say you are expecting that in the evening from 6 p.m. to 10 p.m., let's say there's a match going on and a lot of applications would write data. And let's say you are expecting 1 GB per second of write. So in that case, you can calculate the number of shards that you would need for those 4 hours. But throughout the day, that is not needed. So in that case, just before start of the match, you can change it to on demand. And once the match is over, you can change it to provision. So you can do this to save cost. One important thing that I wanted to tell you is whenever you create a KDS with on-demand capacity mode, by default, you'll get 4 shards. That means you'll get a write capacity of 4 megabytes per second and read capacity of 8 megabytes per second. That is the default behavior of on-demand capacity mode. The moment you use on-demand, you'll get 4 shards by default. And if you need more than that, KDS will automatically scale up. And when you don't need those many shards, KDS will scale down. So that is the behavior of on-demand capacity mode when you start. Now there's one more capacity called warm throughput. So let's see what this warm throughput is. We can enable this warm throughput, but to enable this, it needs on-demand advantage mode. But the question is, what is the purpose of warm throughput? Let's take the same example again, wherein you have a cricket match starting from 6 p.m. and it will go until 10 p.m. for a duration of 4 hours. And you have provision mode. Now let's say you want to change the capacity mode to on demand just before the match. What Kinesis would do, it would create the shards then and there. So it will take some time for number of shards to be available. But if you do not want that, if you want that whenever you scale, whenever you change it to on demand, those number of shards are available instantaneously, use the warm throughput. So in that case, those many shards would be available to you beforehand. Now the question is, what would be the number of shards? Now in case of provisioned, we have seen that we have to mention the number of shards when you create the KDS. But in case of on-demand, that is not the case. By default, you'll get only 4 shards. Now let's say suddenly you need 6 shards. So on-demand would scale up to 6 shards because you need 6 Mbps of write throughput. And what it would do, it would make sure in the backend that for the next time you have capacity available for 12 Mbps, which is 2 times the previous peak. In our case, it is 6 Mbps. So Kinesis would make sure that 12 shards are available so that your application can reach up to 12 Mbps of throughput. Why Kinesis does this? The reason is because adding shards takes time. So till the time the shards are available, and if you are sending write requests more than the available shards, those additional write requests would fail. For example, let's say I have created this on-demand capacity mode. By default, you have 4 megabytes per second of write available now. What if you send 5 megabytes per second of writes, or let's say 5,000 records per second? The additional 1000 records would be throttled, would fail. The write of those records to Kinesis would fail. So that's why Kinesis would make sure that twice the capacity is available. So if your peak goes to, let's say, 3 megabytes per second, Kinesis in the background will create shards so that it can support 6 megabytes per second. Now let's say after some time you have a write throughput of 8 megabytes per second, but Kinesis has only 6 shards. So only 6 Mbps of throughput would be supported. Additional 2 Mbps would be failed or throttled. But in the backend, Kinesis would make sure that your next peak is not throttled. So because you have gone to 8 Mbps, Kinesis would make sure that there are enough shards to support 16 Mbps. Now it would keep on doing so throughout the day if your peak changes. As you can imagine that even though on-demand mode would automatically scale, there are still chances that your write requests may be throttled. Let's say instead of 16 Mbps, you send 20 Mbps of writes. Now 4 Mbps would be throttled, and that's where warm throughput plays a vital role. If you enable warm throughput, then Kinesis would make sure that certain amount of capacity is available. So let's say you are expecting 50 Mbps of writes per second in a day. So you use warm throughput, you enable warm throughput, and you mention that maybe sometime in the day I will have 50 Mbps of write, but right now I have only 12 shards, which is 12 Mbps. So in that case, Kinesis would create the shards in the backend and keep it ready for you. There would be one-time charge, and you can go back to using 12 Mbps of throughput. Now, whenever that peak comes, Kinesis would be able to support that peak because you had already provisioned as such. So that's what warm throughput is. All right, so this is something that I wanted to talk about. So then you have other configurations also like maximum record size, tags, and encryption. I have not enabled encryption. I hope you already know what encryption is. By default, the data retention is 1 day. You can change it to 365 days. The maximum can be 365 days and minimum has to be 1 day. So I'll not change it. I'll keep it as 1 day. After 1 day, the records would be deleted automatically. You do not have to delete it. Then you can enable enhanced shard level matrix. This is not free of cost. You'll have to pay some price for this. Now, enhanced fan out is another feature which we'll talk about when I discuss reading from Kinesis. Then you have Kinesis data viewer, and you can look at what data are there in your Kinesis streams. Kinesis data analytics is nothing but data analytics with Apache Flink. We can share the data stream also. You can create a resource-based policy using which you can share the KDS. Then you have Amazon Event Bridge pipes. The source can be Kinesis. You can filter the data and send it to Event Bridge. Again, this is something that we'll not talk about. This is in a nutshell what Kinesis data streams is and how you can create and configure a Kinesis data stream. In the hands-on that I'm going to show you later on, I'll be using this same KDS stream to write data to and read data from Kinesis.